All right, we're at section 18.2, thermometers and the Celsius temperature scale. Before I go to the PowerPoint, I want to show you a couple of thermometers that I have. This one is just a little room temperature thermometer, and you can, on this side we have Fahrenheit, and on this side, we have Celsius. A few things to notice. I'll show these in more detail. You can see that right now it's about 70 degrees in the house here. You notice here, 40 degrees Fahrenheit is equal to 40 degrees Celsius. It's the one point where they're both the same temperature, Celsius and Fahrenheit. If somebody says, well, it's minus 40 degrees outside, you don't have to say, well, it's Fahrenheit or Celsius. It's the same. If you look at 0 degrees Celsius, that's 32 degrees Fahrenheit. If you look at another one to notice here is 37 degrees. 37 degrees is 98.6. 37 degrees Celsius is body temperature. Now there's liquid alcohol in this column here, and the temperature is related to the thermal expansion of alcohol. It's a known rate, and so they calibrate it to where you can use the expansion of alcohol in the to calibrate the thermometer. Now this one is a little refrigerator thermometer. You hang it in your refrigerator, and you can tell if your refrigerator is working properly. And if I were to take the back off of this refrigerator thermometer, you would see a very tightly wound coil, and the coil in there is actually two different metals that expand at different rates, so that they're fused together. So as the temperature changes, the coil will wrap or unwrap depending on if it expands. I think it probably unwraps. One is getting bigger, and it'll go further down the dial. If it gets colder, it contracts, and it goes down to over here to this morning I saw it at 32. It was cold this morning. Okay, so that's a little intro. So thermometers, let's share the PowerPoint. The thermometers, they're based on principles of some physical property. As the system changes, the property changes, such as the volume of a liquid, the dimensions of a solid, such as that spring. You've got the two different metals of the spring. Those dimensions change. One is getting longer. The pressure of a gas at a constant temperature, the constant volume, or the volume of a gas at a constant pressure. The electric resistance of a conductor, or the color of an object. So they calibrate these by putting into known conditions. If you have a mixture of water and ice in thermal equilibrium, on the Celsius scale, that's 0 degrees. So you put it in a nice bath and it comes to equilibrium. You can say, okay, that's 0 degrees C. Then you mix it in water and steam. Mixture of water and steam in thermal equilibrium, that's going to, at atmospheric pressure, that's going to be 100 degrees C. So that's your next set point. And between that 0 and that 100, you divide it into 100 little segments, and you've got a Celsius scale. Now they have their limitations. Different, you can't, for an alcohol thermometer, you can't go beyond 85 degrees C, which is the you can't ever measure boiling point, because it would the alcohol itself would boil. And mercury, well, you can't go past 39 degrees because that's the freezing point of mercury. In the next section, we're going to talk about the gas thermometer, and I have a little scale here that I wrote down um, these important uh, these important ones for you to remember. And actually, if you remember these, you can come up with your own conversion for uh, converting from Fahrenheit to Celsius and Celsius to Fahrenheit. I may make it as an extra point if somebody wants to come up with the y equals mx plus b. You can do like 40 and 40 and 212 and 100, or pick two other points, and you can come up with a y equals mx plus b equation to give me the conversion. I'm going to give you the conversion later on, but I just would like to see if you know the steps to convert it in yourself. If you do, then you never have to memorize a formula. You can just derive it on the spot. Okay, so we said that at 40 degrees F equals 40 degrees C. Now here the horizontal scale is just the position of my calculation. It's really the vertical scale that you want to pay attention. This is degrees, irrespective of whether it's Fahrenheit or Celsius. It's just degrees. So minus 40 is equal to minus 40. And then at 0 degrees C, the red is Celsius. 0 degrees C, we have 32 degrees F. At 37 degrees C, we have 98.6 body temperature. That's another one to remember. And then at 100 degrees C, we have 212 degrees Fahrenheit, the boiling point of water. Okay, so sorry, just kind of hand drawn. I made it myself, but just to show you these 4 points that are, you can always use these to derive your own conversion equation for temperature, switching between Celsius and Fahrenheit. Okay, the next we're going to study the constant volume gas thermometer.